we're still continuing to work with the scalar triple product and proving various identities of it using the epsilon permutation symbol. In the last video, we proved this and this to be equal. Now in this video, we very quickly want to prove the rest of these identities. And here we can pick up the pace quite a bit because we're going to build upon the background that we accomplished in video number 6. Now, here's a scalar triple product, jki, but remember that jki, that is the same thing as kij. They both have a value of +1. So we could write this as equals epsilon kij. And we're free to move these scalars around as we want, so we can make these vectors, or that we can make these indexes match. So we'll have ck ai b sub j. And again, the reason why we can is that these are components of vectors, these are scalars, and all we are doing is giving this a number 1, 2, and 3, giving this an independent number 1, 2, and 3, giving this an independent number 1, 2, and 3. So we're multiplying scalars and adding them. The order in which we do it doesn't matter. It gives us the same result either way. But as we shuffle the scalars, then we want to look at what this means. And proceeding as we did in the previous video, we would say, well, this would be C cross A, vector C, cross vector A. Ki, it would be the jth component of it. So this is equal to Bj times C cross A j. And this is just component form then of this dot product. B dot C cross A. Just like we did in the previous video. And that is equal to A dot B cross C. Or in abbreviated form, ABC equals BCA. And that's this. Now let's move on to these. Same procedure, except now we're going to have some negative signs that will be appearing. We go back. Here's our expression, jki, but now jki, that would also be minus jki would be, say, the negative of kji. This is +1 and this is -1. So you could say this will equal minus epsilon kji. Now we arrange the scalars so that the indexes match, and we have ck b sub j ai. And this, that would be C cross B, Kj, missing letter is I, it would be the ith component of that. So this would equal A sub I with a minus sign before it times this. But this, again, is a component form of minus A dot C cross B. So we have A dot B cross C equals this, or we would have it in abbreviated form, we'd even bother to write in that for our abbreviated form, ABC equals minus ACB. And that is right here. Now we continue along doing the same type of thing. And again, we're going through all the possible examples just to get used to working with the epsilon permutation symbol. We have here JKI, but that could also be JIK. But JIK, that's the opposite of this. That's minus 1. So this would be, this is negative that. JIK would be minus JKI. This is minus 1. That's plus 1. But then, if you write it like that, we have to rearrange our scalars. This would be B sub j. Then we have A sub I. C sub k. But this, that would be B cross A. JI, missing letter is K. So this would be equal to minus this component, CK, and this component, B cross A, kth component. But this then is just component form for this dot product. C dot B cross A. And that equals, we've got our minus sign, or an abbreviated form, A, B, C equals minus C, B, A. And that's this identity. Or, going back up to here, we have JKI. That would be the negative of IKJ. This is plus 1, this is minus 1, so we could write equals minus epsilon IKJ. And again, rearrange these so we have AI CK B sub j. I, K, J. These match. And again, we're free to do this. We can shuffle these scalars around because all we're doing is multiplying and adding scalars together. The order which we do it doesn't matter. But when we do make the change, now it's important to look at it and say, well, no, wait, what does this mean? That would be A cross C, IK, the missing letter is J. So this is equal to minus the component B sub J times this component, A cross C J. But this is just component form for this dot product, B dot A cross C. And we keep forgetting to take our minus sign down. And that is A dot B cross C. So we've established this identity, A, B, C equals minus B, A, C. And that's our final identity. So again, we want to kind of get a workout here, getting used to working with the epsilon permutation symbol, and we've used it just to prove a real simple set of identities using the for the scalar triple product. Now, with all this background, then what we'll do in the next video is prove this equation, and then we will use that equation to prove very complicated vector identity problems. So that is what we'll be doing in video number 8, tackling this identity. So continue with us, and we will explain what this is, we'll prove why it is the way it is, and then we can use this as a very powerful tool. And the playlist for the vector analysis series is at the website digital-university.org.